Hello, hello, it's Mecha Sparrow. I'm studying C and C++ again. Yeah. Just have to get the voice cracks out of the way and then we shall be able to get started. And I guess, I feel like C covers most of what I need to know. And once I get C covered, I think I'll just probably skim over some C++ stuff after I do if I find like some coding challenge site. But let's see, we are on, I don't need the reference, well, we'll see about that. Appendix stuff I think I can look at later on, but it's like extra whatever, not extra, well, just extra stuff. I might have to use that at some point, but that is debatable. And then let's wait, and then we are good on the stream. It says that we're streaming on both things, so that's good. I wish that there was like some notifier that I was streaming. It says I'm sending data, which is good. RTMP, actually look at my site, or my thing, it says 3 frames per second. Okay, I'm live on YouTube, so that's good. Right, I'm gonna post on, grab my link from Twitch. Perfect, okay, let's get started. So, we are on chapter 6 of the C programming language, where I am learning about, well actually not chapter 6, I am actually on chapter 7. I did chapter 6 yesterday. So I guess I would be chapter 7, 151. Okay, there we go. Alright, we're good. Input and output facilities are not part of C language, nonetheless programs interact with the environment. ANSI standard defines these library functions, so they compile in each. C properties, specify multiple headers, C standard IO, string, C type. We will not present the entire library here since we are more interested in writing C programs. Library described in more detail in Appendix B. That's fine. Standard input and output. So we can, the simplest input mechanism is reading one character at a time from standard input. Normally keyboard via getchar. Getchar returns next input character each time until EOF encounters under the file. Okay. And then if we want to, instead of input, we can actually just like pass in a file contents, which is okay. We can also use a pipe. The function is used for output. Putchar puts a character out on the standard output, which I guess is the same thing. So it prints it out to the output stream. Makes sense. Let's see, standard IO is stdio. to lower, it's from C type, just lowercase, okay. Write a program that converts uppercase to lowercase or lowercase to uppercase depending on the name it is invoked with as found in argv. I forgot how to do that. I'll put that on to-do list. argv, I haven't written any programs for that yet, but I know how to do it in theory, which is good enough. Formatted output, printf. Format and the arguments. Printf converts formats and prints its arguments in Siren output. It returns number of characters printed. Format string contains two types of objects, ordinary characters, and then special conversions. Minus sign. Period, number. Okay, that's a lot of stuff. And they have special ones where it's like, okay, if you use D or I, that's int. O is an octal. X, or capital X is hexadecimal. You can even print out a pointer, which is interesting. Then if you do 2, it's just a percentage sign. The width of, or precision may be specified as, in which case is computed. Okay. We have different examples. Okay. Sprintf. Same conversions, but stores output in a string. Okay, that's actually pretty useful. I can see using that for sprintf. Write a program that will print out arbitrary input in a sensible way. And this talks about how it's actually implemented. File access, that's interesting. Okay, so xrc, y.c. So when we have a file, just pointer to the file basically. If opens the file. There's ways to actually write to and push to. Okay. There's, okay. Calec n size returns a pointer for an array of n objects. Specify size or null. Okay. Proper alignment for the object in question, but it must be cast in the appropriate type as IP equals the end pointer calec. Okay. Frees a space pointed to by p, where p was originally obtained by a malloc or calec. Cosine A tan exponent, okay. Square root, power, log, okay. Random number generation, and computes a sequence of pseudo-random from 0 to random x. Oh, it's just random function, okay. And then this is for, oh, this is for converting to float. Got it. Unix system interface, file descriptors. What does it say? Set of system calls, which are in effect functions. This chapter describes how to use most of the important system calls. So this is like, if you're like, well, I mean, if the C is written in Unix, let's just use stuff from the Unix system. So it's like, okay, if the user, they can interact stuff through that. So they can say, okay, I want to pass this to that, okay, and vice versa. And then low level IO, which is access, blah, blah, blah. Second argument is the character array, where the data is to go or come from. just call so it reads from run stream. Hello, welcome to the live stream. If you're new, I'm studying computer science stuff because I want to get a head start before I have to go to college, basically. So there's that. Trying to think what else. And then I don't know, I want to make sure to have a slightly solid foundation in C before I get there so I can like not stress it out, I suppose. Most common values are 1. Okay, cool. Character at a time. So read from one stream. This is what I'm getting. It's like second argument. So you have character buffers. Okay, character buffer 1, character buffer 2. So you're reading from a character buffer, writing to a character buffer. Got it. Makes sense. Copy input to output. You have a character buffer. You have the int. You say while you're reading from 0 from the character buffer, buff size. Then write that character buffer to the output. So this part, that's what's being defined. Okay. So they can say, well, you could use fopen or you can use open, which just returns a file descriptor, returns -1 if error occurs, and there's specific flags for what you want to do with that file, which is okay. So for creating file, I'm trying to figure out what would the use case be for me using system calls instead of just the ones that they give me inside the system IO. Because I mean, all this stuff is like, this is just shorthand, basically. Like, this person is just showing me a bunch of shorthand. I actually have to write out the calls for that. Like, I don't think that there's actually a C read. Maybe there is. But see, it's not exactly, it's like SS size TP read. Like, it's a bunch of, it's not just read, it's all that. So like, they're simplifying it for the sake of just talking about it. So, okay, void error CP copy F1 to F2. Here's our arguments, here's our files, here's our buffer. If it's not equal to 3, then we're like, okay, this is wrong. F1 is equal to open, and then we use this to open up that file, and then it ties it to, I guess, as a file descriptor. Yeah, file descriptor, another file descriptor, and then using F2, it writes to the buffer, and then, so it reads from this, and what does it do? It reads to it, and it puts it in the buffer, and then when that happens, then it writes to the buffer. I think that's what this code's doing, basically. Because this is a char array. So the buffer is a char array. So it's like first we're reading into the buffer, then we're writing out with the buffer. And this is specific permission flag for making it read-write, basically, I think. This too stuff is if you want to read and write, I guess, in random places on the file. So you have a file position. Ah, yes, true. The true caveman to his brother. Well, C and C++ are pretty much the same. So I'm like, well, I can learn C first, and then I can learn C++ after this, and I can upgrade to the big boy book, the C++ programming language, basically. I feel like C is a pretty well put together language, at least from what I've seen. Like, I feel it's pretty heavy. Like, I'm trying to figure out use cases for it. Like, I have to, like, force myself to think of a use case. But I feel like it gives you enough rope to, like, mess up. Well, that's good. I mean, I feel like if you know C++, I think learning C is a bit, it's not that bad, because it's still relatively the same format. I feel like C++ versus C differences. The major difference is that C is procedural, does not support classes and objects, while C++ is a combination. Therefore, C++ is, let's do this. Let's look at that. Blah, 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 blah. C++ is a superset of C. C++ can run most of C code, while C cannot run C++ code. Let's see. Procedural. C does not support object-oriented programming, so none of these beautiful things that if you're used to object-oriented programming. C++, on the other hand, does support all those things. C++, so data and functions can be tied to objects, so creating classes, right? Mostly just a lot of object stuff, and then C++ uses namespaces for avoiding name collisions. And then they have slightly different I/O. Reference variables, I feel like maybe that's an advanced version of pointers. I don't know with virtual inference stuff. Malloc and calloc functions for dynamic memory allocation. C++ uses new. Okay, I guess C++ uses a little bit of kinder ways for memory management. But basically, the way it's set up is that was a decent article. I feel like Geeks for Geeks, different Guru 99. Ooh, Stack Exchange should be good, interesting. I have like probably like couple more pages before I'm actually done with the C book. And then I think what I'll do from there is I'll tackle a couple of just like C programming challenges, like from some koans, and then we'll jump into C++. Let's see. Many times, blah, blah, blah. I'm using Visual Studio Code, and then I'm just going to be using the standard GNU compiler for compiling it with its with preferred flags. Everything. So because Visual Studio Code, they have some pretty indecent. Let's see. They have some pretty decent IntelliSense for the C and C++ programming. C++ is different, just same syntax. Oof, okay, well, that's good to hear. I mean, if you really wanted to, you could just program C and C++ in like Vim or Emacs or like Nano, but as long as you're on either Mac OS or Linux, any Mac OS or Linux system, Unix system, then they should have tools in place. Lseek, blah blah blah. File pointer. fopen get char. See, like, I like all this stuff, but this doesn't. There's a part where it just feels like it kind of falls out of my mind because it's just it's not very relevant in terms of like, am I gonna use this? Yeah, I mean, well, Windows you can install a subsystem, Linux subsystem to work on the C stuff, or you can use Visual C. There's a system for doing C and C++ programming on Windows if you desire. So this convention is used by all that fun stuff. Data structures, describe file. I don't even need to know this stuff because this is just being like, hey, this is how we implemented those functions, which is fine, but not of my concern. Yeah. File buff, blah blah blah. This is basically like, oh, it's like I understand it, but I like don't want to think about it too much. I'm like want to try to program some stuff on it. Dev T, a bunch of, so it's like, okay, let's assume you know Unix. This is how you go in depth into it. Closed door. I feel like I could have skipped the chapter, honestly. And this part, like, oof. This is just like, hey, here's how we implement malloc. So they use a union, and the size, and then the alignment is really weird. It's not consistent alignment for depending on the types. So what do they use? They basically use their own. I guess for the thing they use their own data type. And they have set up, they don't set up char array, they set up block array. Okay, that's okay, I get that, I see. That makes things a lot more sense. So they just use their own self-defined data type. So that way, this thing, and then they do a union header or a size. So it's either size or a header pointer. Okay, I've returned. No! That's going on YouTube, that's the sad part. It's like, because I'm gonna be archiving my streams. Because I'm streaming to both. It's whatever. Me? Is it? I don't know. It's hot in here, that's why. Great question. That means that the heat's working. No. Yes, thank you. Let's see. Malik does what Malik does. That's the way I can sum it up. Oh yeah, that was okay. You're right. I see. Okay. Free is the last thing. Free basically is just inverse, I suppose. Just freeze it up, makes it set to whatever it needs to be. Is that it? Am I done? And then there's the reference manual. I'm not reading the reference manual. Okay. C colons. C++ codes. No. Rootless root. Unix conons. Oh, is this a meme? No, this is a meme. I'm not gonna gain enlightenment through whatever the C colons. No, let's see. Let's do hacker rank. Or, code challenge websites. What's a good code challenge website I can do? Exorcism? Yes, I accept all these things. I don't really want to get emailed for those things, so I'll just be fine. Ballerina, let's start with that. No, it's 57 exercises. Alright. 19 mentors, blah 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 blah. Let's go. Mentored mode. You can join this structured approach centered around feedback independent mode, which allows you to follow your own path. If you're unsure, we recommend with mentored mode. Psych, let's do independent mode. I am a independent learner. Let's do this. Hello world. Make test. Okay. And then I'll do this and I'll be like, ah, nice. Okay, let's start. Get started. Begin. Oh, I have to install Exorcism. Oh, you install the Exorcism, use your code, then you can submit it. Huh. Okay, I see. Alright. I get it. So I have to install Exorcism. Oh, and I can even become a mentor, so like I can be like, yo, I can teach Python. Or C#, or mostly Python. Okay. Well, let's see. Installing Okay, this is actually, this is legit. Let's do this. Let's do this. Okay. So if I want to install, how do I install Exorcism? Installing Exorcism. I feel like I'm already feeling the enlightenment right now. This is great. Okay. If you sign up, and I have to, do I have to use my email? Just gonna go on a separate page. And then, hey, I can do. Submit your, you will see, begin walkthrough. So I just start here. I go on Hello World, begin walkthrough, and let's say we're on Linux. That's easy. Do you know your process? Yes, I do. Download the appropriate. Wow, I feel this is great. Okay, we're doing Exorcism 64-bit. Yeah, this is legit. Okay, that's cool. This is how I'm pumped. I hope I don't sound like really sarcastic, but like it's definitely something. Okay, and then they're like, well, let's say you are on whateame, you can just do this. I'm like, cool. And then I can just move. Is that just a script? Is that all it is? Is it? Is it just a script? Okay. Then what? I have this. That means it works. Yes. Okay, we are good. So yes, is it outputting something like above? It is. I already did that. Okay, please don't steal this from me. It's my personal token, unless you want to like be like, oh, Michael's super good at whatever. That's you can do that, but I wouldn't recommend it. Congratulations. Yes, we did it. Okay, perfect. Start with Hello World. Let's get started. This included makefile, copy. Where's Exorcism? Oh, okay. Perfect. And then we can just pull it up in my Visual Studio editor. Well, I guess I have to open it as a folder. And, okay, let's open the terminal. So if I want to do this, well, make test. And then we can see what the error is. Control reaches end of non-valid function. No return type. Non-void function. And function hello world. So let's see. Does not return anything. So it needs to return a char. So, and what is it looking for? It wants us to do hello world. Okay. Perfect. We can do that. because this will be considered a string constant, and a string constant is shorthand for a perfect. And once we do it, we can just copy that, and then we can be like path to file, and I guess what we're just submitting, what are we submitting? Just the final, let's see what it says. Try to use standard C99, tag the time to refactor. Hello. Red 3000 HP. Nice to meet you. Okay, I guess I just submit it, and if it works, it works. So we are in the hello world directory, and I go to source. Oh, okay. Does this work? Your solution has been successfully submitted. You can complete the exorcism. So now what? So, and I did it. And this is what I got. Then I can download my solution. And then once, if you're happy, you can mark it as completed. You will be then allowed to publish it. Explore more solutions. Yes, let's see what other people did. And then I'm going to complete this solution. I'm reflecting. Make your solution public. No. Well, no. Sadly. Let's see what other people did. Basically the same thing. Yeah, okay. Next. Well, it's all the same, so let's just say it's fine. Alright, next one. ISOGram. What am I doing? So what I'm doing is there's this wonderful website called exorcism.io. And what I'm doing is I'm teaching myself C, so that way I can use it to learn other computer science fundamentals. Well, just so I have a stable base. The base of the base, let's put it that way. And then I can learn C++, which I don't know what I'm going to use, but I think what I'm going to do for C, since I just learned a bunch of random C stuff, is maybe like learn just how to render maybe like a basic raycaster for fun, just to make it feel like I did something with C, but right now I'm just doing a bunch of C challenges. So what's this say? ISOGram is a non-pattern word, is a word or phrase without any repeating letter. Okay, sounds simple enough. Okay. So let's do it. And then like, this is the C stream, and then I'll switch over the thing to once I do Lisp or Racket. Racket's a little bit different. Racket is a little bit more like, okay, how do you make a good program type of thing. Yeah. It just so happens that the book's written as a Lisp thing. Okay, Boolean. So now, test, set up, tear down. So what's the difference now? Yeah, Lisp is basically this a different type of programming language that uses a lot of curly braces. Why are you doing this? Because I just want to know a lot about computer science. So preferably once I go to college, where I'm going to be majoring in computer science, I can just tutor people, or I can just focus on building my stuff. And whenever I have to do any computer science stuff, like in a class, I can just focus on, just do whatever, and then have a lot of extra time just to build what I want to build, or anything like that. Okay, let's do isogram.c. So we defined this, and we're saying, well, we have to implement this function. Yes, I did just graduate high school. I'm going into college this year, so in fall, in August. Yeah, that's basically the goal. What's this saying? Well, I need to return a bool. Bool is not defined. Quick fix. Oof. What do they mean by bool? Go off, skinny queen. Control, can I do return false? Why would they make ISOGram? Oh, that was a L. Oof. Oh man. Unused parameter. Thank you for letting me know. Test.out failed. What is a test? Cool. Alright, so if is a ISOGram, spaces and hyphens are allowed. It's a word or phrasing without any repeating letter. So that's the main characteristic of it. Yes, I'm quite aware of how Booleans work. Thank you for the reminder, though. Bool result. Let's set this initially to be false. And then what I just want to do is I want to test. Why? Oh yeah. Well, I guess so. Alright, a phrase. I have a feeling like you don't, but if you're right, we'll see. Well, okay, let's just do it as a sanity check. So char, constant char phrase. So this is just a string. So, but I know how we can do it. So so int I equals 0, and I is, I can say phrase dot I not equal to that I plus plus. Why? What's the error? What's the error? I think it compiles fine. No, line 2 isn't an error. This is valid. You mean line 1? Hell, I think you don't even need semicolons for that. Yeah, you don't. These two lines are preprocessors, so they don't care about the semicolons. Implicit in function, implicit declaration of printf. Why so? What does my makefile say? I feel like this should be valid. Error, control reaches, yeah, I understand that. Yeah, okay, that's what I thought. Expected true. Yes, I understand that. Okay, so let's say, what are we dealing with here? The challenge is isograms, no repetitions. Yeah, I don't use Enki as much as I used to, though. Let's think about this. I'm 18. Missouri? Let's see. Why? Why are you using Anki? I feel like this is gonna be really, interesting. Oh yeah, okay, that makes sense. Let's do type def. Type def. Word. Letter. Yeah. Oh yeah, why am I doing this? Okay, I have an idea. Okay, let's do. Alright. 10? When I was 10? C is a lot different than what I'm used to programming. Okay. If we were going to count the occurrences, we have to basically create a list of letters. This is my first week. This is my first week learning C. I don't see what the expectation is here, but thank you for the observation. I think I got it. I know what we're doing. I'm more used to doing JavaScript and Python. Okay, I figured out what we're dealing with now. Letters, perfect. Okay, so I just have to do ASCII, right? So I can just say, so let's create a list. We can do this. So let's do a char. We just have to accumulate a occurrences. Yeah, but my college teaches it, so char occurrences. Let's make it just size of z minus a we'll do that plus z minus a. Yeah, this is a struggle, I'll tell you that. I really am, okay. Try using standard C99 facilities and preference to writing your own low level. C will give you great fundamental. Okay, use standard C99 facilities. Yes, let's do that. Well, that's the thing. Like, I can read the book, but the book isn't necessarily gonna do anything per se. It doesn't necessarily work like that, but yeah. Okay, said who? Give me an example of a program that does something. I'm gonna use something else. Accessor system is okay, but let's look at the other ones. Yes, but like, what do you have any examples that you want? Anything in particular you think I should build? Okay, let's start with the easy ones, and then we'll work our way up. And yes, we will build something. Here's the goal. I will build a couple I'll work on a couple challenges, and I'll build some simple thing in C, and then I will move over to whatever I was thinking of later. So let's start with the first one and then work our way up. Skip. Okay, simple. Why did it use C++? I don't know. Let's do this. What's the sign? Oh, I get it. Yeah. Given the numbers 2, 7, 11, 15, return indices of two numbers such that they add up to the specific target. So because of nums 0 and nums 1, they add to 9. Okay. So they're saying, well, find two numbers okay. Is there a way to test it? I know. I'm just testing it. Oh. Give me a second. Okay, STOut test, that's perfect. So here's what we will do. We'll write a simple for loop, because we got a size, so we'll do for int I equals 0, I is less than num's size, I plus plus, printf, %d, then let's do num's size, num's I, let's go with that. I'm just poking around right now. I'm just trying to get the feels for it. STOut 2, 7, 11, 15, right? Then we have, let's do int, let's do lm, let's do int pointer, let's do lm1. Then we'll have int another one, lm2. And then it says, what does assume? Returned array must be malloc, assume color calls free. Okay. So we'll take this guy and we'll say, well, excluding himself, so we'll say lm1 equals the address of do nums plus I, and then lm2 that will figure out. I would agree, but I'm doing this because at some point they will make me do this in the college. Okay, we're getting closer. So grab first lm, and we go iterate through it should return mat instead of 0 to avoid. Oh, okay. Okay. I hope that doesn't. It's judging the code. That's even worse. Thank you. It'll be an interesting battle. Okay. Good. Yeah, I know, I got there. I figured it out. For int z equals 0 and I is less than num z is less than num's size z plus plus. This is going to be highly inefficient, by the way. This is already what? It's probably n squared, which is okay. If lm1 equals lm2 let's do this. If lm, yeah, this doesn't matter. lm1 equals lm2 printf no. Then we can say if lm, okay, here's the thing, you don't want to use goto statements. It's preferable that you don't. Also, and the fact that it's on a single line, I don't think that's necessarily good in terms of readability. And then we're going to dereference these. That's fine. Let's see. What does the code say? Output stdout. Was there any time when it actually got the right answer? What? It's fine, guys. I don't care. I'm in the zone. If the dereference is this target a pointer? No, it's not. Let's do int result equals the dereference of lm1. My apologies. Does it ever get to this? No, it doesn't.
Are you hungry?
Yeah, I'll be hungry.
Michael's hungry.
I might be wrong. I don't know anything. I'm just an 18-year-old. Let's see. For type, it's fine. Let's do this. And okay, I'm taking a dinner break. I'll be back. Be back in like 5-ish minutes. I have returned. Okay. Yeah, I mean, programming is very subjective. Okay, let's do this. Okay, let's try this. Let's dereference this one. And then let's hope that it prints out here. Okay. So whatever's happening here is not working because of what? Misaligned address. Let's see. Misaligned address. Let's see. I've built things before, it's just right now I'm trying to figure out how to solve this problem. Yeah, I'm Googling it right now. Let's see. Jadrowski's a pretty interesting guy. He's there's memes about him, like good programmer memes. Line 28. Alright. Misaligned address. Let's just do this. And semicolons. Oh my. I am not used to writing semicolons sometimes. Okay, that works. We have LM1, LM2. Right? These point to a dereference. So I guess that's not good. Or no, this should just be... Okay, this is starting to make... I think I'm getting there. This is making sense now. Okay, now... I think that was the aha moment. Let's try that. But there was a heap overflow. This 18. If. Okay, let's try this. If. Let's just do that. And LM3. So that way we're not overdoing it. Okay. If LM3 equals target, then we can say printf success. Yes, okay, I think we're on the right route. And then the first time we have a success, then we can just break. And then we have I and Z. So let's do int I, and then int Z. And then we just do that. And the reason why we're just doing that is because the whole description was to return the indexes, and they want to return it in a int pointer system. Okay, that's fine. So then I guess we just malloc to results. Let's malloc 2 ints, right? And then we can just say res dot 0 is I, res 1 is Z. Can we do that? Why am I getting... It's not good. Assignment 2. Oh, let's try that. Segfault perhaps, yeah. I think not. I think we're good. Well, we're getting there. Let's submit again. Segfault. These are all old errors though, so it gets a. Does it want us to do it from stdio? Return, and that's what I'm returning, right? LM2 and LM1 are pointers. Does it want me to print it out? It's really odd. It ends. Okay, so it breaks here. Then I have to break 2 times. If lm3, well then if lm3 equals target here, break. Let's do that. Let's see if that works. It's fine because I did run it. Buffer overflow. Oh, I'm getting buffer overflow. And I'm doing that. I can refresh the code. Am I going over maybe? That like I'm going into some bad realm. Okay, where's it getting? Where's it getting a... Okay, what are people doing? Well, I don't want it in Java. Yes, this is what I did. Return int. Is that what it wants? Does it want me to return that specifically? Like I can return a int and the iz. Does it want that? Let's see. I mean, I think it changed. What if I do it in Python? Well, okay, here's the thing. Why is it thinking the output is like a bracket? Bracket output code. No. Return format for lead code. Okay, so because this works, right? But for some reason, I return it, right? And it thinks that yeah, well, I'm not returning anything until the very end. Yeah. Well, I allocate it. I said it's 2 numbers. It says assume caller calls free. Return size. That might be it. Do they maybe want me to do return? Maybe they want me to allocate it to a return size? What if, okay, so what happens when I return? Is that what, well, I mean, is that what they want though? No. Yeah. Let's see. Run. Expected expression. This is expression. Time limit. There was a time limit? Okay, you know what? I have, this is a fail-safe thing. Project ruler. No. Yeah, I wanted to see if it was gonna work though. I changed it to this. Very funny idea, but no. Thanks for the follow. You can try it out if you want. I'm gonna do something that's actually not gonna pester me about those errors. Okay, this is very simple. If we list all the natural numbers below 10 that are multiples of blah blah blah, the sum of these numbers is 23. Find the sum of all the multiples below of 3 or 5 below 1000. Okay, great.
Michael, where's your laptop charger?
It's in the backpack.
Where?
It's in the backpack.
Where?
In the front part of it. Yeah.
Michael's not there.
Check, Andrew, check your room.
Michael.
Andrew, check your room.
Can you check this?
No. Andrew, I'm live streaming right now.
I need it.
Andrew, check. It's in your room.
It's in my room.
Yes. Okay. Let's do this. Multiples. .c. I know. Okay, this feels a lot better. Okay, we are definitely making some progress right now. So I is less than or equal to n, I plus plus. Okay, so we can say, then let's do int multiples, get multiples, bool m question mark is multiple I if m print f is a multiple, then I, else. We're not testing, we don't need test 0. Okay, is this good? This is a good size. I think it was a good size. Yeah, it's a good size, I feel like. Okay. Printf if m printf else printf not a multiple. I'll be right back. I need to close my door. Okay. Yes. Did you discover how lead code is so messed up? Yeah, that's what I was saying, and like, because I was 99% sure I got the right code. It was because it replicated exactly what the brute force method was. Yeah. Yeah, like that's basically what I wrote, but yours is more concise version. So we're not going to need this, and it will be obvious why. And yes, this will actually... Yeah, I know. Yeah, that's how Google gets you. Yeah, I am. Well, I'm learning C for fun. Oh boy. If I is less than n, but I becomes 302. Huh. I give it 10. So I feel like we might have gone over. Am I using the same I? No, I'm not. Did my music go down? Yes. Yeah, that's what I was saying, and that's what I was struggling with, man. It hurts, man. It hurts a lot when that happens. Let's see. No, is it good? I might try it out. I'm getting closer. I can feel it. I am printing out a pointer, right? So what's the issue here? For int I, I am incrementing, right? Yeah, I know. Thanks for the follow, man. Let's see. Well, to test it, we can say, well, let's do nums plus I minus 1. See what happens when we do that. This is Project Euler. Well, this is just my own text editor. And like this code would probably take not as long as this. It would probably take maybe 5 minutes in Python. So it hits 0 first. And because it hits 0, I shouldn't be adding anything that's 0. Thanks for the follow. Keep finding like 20 different ways to break this. Okay, perfect. Good. Okay, now we can start from this again. We have this, and we are like, okay, cool. Then we're gonna have the last one be set to null, right? Can we do that? Yes, we can. So if I do if for int I equals 0, and if we do for I equals 0, and then we do multiples I does not equal null, I plus plus, def, wow. Okay. So that doesn't do anything. Can we do this? Okay. So I'm guessing that I can just do sum equals 0. Because I have been obviously overthinking it this whole time. I don't even need pointers, I just need to use is multiple, basically. If what was the one thing you said? Code signal? It doesn't look really free. Okay, so here's what we're gonna do. I'm gonna take a break. This is valid, actually. This works enough. I'm gonna take a break from C for a bit. Then what? So then I'm gonna do Lisp. And then, so I'll do Lisp for probably 20 minutes. Then wow. Actually, I just have this very simple idea for like a matrix application for vectors. Let's just do that. I want to do that in C real quick. I think I can save the Lisp thing maybe for tomorrow if I want. Probably like a Lenovo ThinkPad. We'll also have, let's do yeah, I think of ThinkPad's pretty good, in my opinion. I forgot how to use structs again. How's the storage size not known? Okay. Thanks for the follow, Math08. Okay, that's a base case. So we have vectors, then we have that, then this. And we include that here. So we have type def. So can we just say this is a struct? Just call it a struct like that. How's it incomplete type? I'm missing something. Let's just do this. Let's just do it with a vector 2 first. Okay, that works. So now what I want to do is instead of using vector 2, I just want to do type def vector 2 vector 2. And I guess this would be struct. Does that work? Okay, and then if I just did this, that works. So then if I did type def struct vector 2 vector 2, and then I did this, right? And then here I just did vector 2, right? Okay, Okay, so then I can take this out, right? Type of formal parameter 1 is incomplete. Well, so that means type def struct vector 2 vector 2. Yes. Okay. Maybe I have to link libraries. Link header file GCC. It's very interesting. Vector 2, vector 2, vector 2. Aha. Yes. Now we're getting somewhere. Okay. So basically, I've been taking linear algebra, and I've decided just to mess around a little bit with some stuff. Just like some stuff I've implemented. Conflicted types vector 2. What? Perfect. Okay. So here we go. I figured it out. Basically, your structs you have to define in your header file. So here's a couple things that I learned about in the thing. So you can do vector addition. So say let's do add vector. So we'll return a vector 2. Vector 2 add vector, and we'll do vector A and vector B. And this just basically you return a vector 2. Let's do vector 2 resultant, which will equal basically a new vector 2 where it's a dot x plus b dot x, then b dot y plus a dot y plus b dot y. And then there's scalars, so we can do vector 2 scale vector. So we can do int scalar vector 2a. So we can do that. Okay, and then I think let's say we also have okay, so let's do vector 2 get vector. Let's do f scan f %d we do back x back y. Then we can do, let's do vector 2 back equals malloc. 0, 5. Perfect. Okay, so then we can do, let's say, let's get 2 vectors, right? So we'll get vector, and we gotta free these stuff. So we'll do free it up. So we'll do free back. Just joined. What are you programming? Oh, I'm programming a linear algebra, just like a basic linear algebra system in C for fun. Also, because I completely failed at doing almost all the C programming challenges because they were just too many stuff that I had to figure out basically. This should work. Okay, so let's say let's do vector A. So vector A will be 0, 4, then vector B. Well, it didn't really wait. Oh, I think it's just scan line C. Scanf for a line. Yeah, I'm trying to figure out how to scan a line right now. Yeah, I think I'm on an oof right now. fscanf, input and output, C. I don't see why it can't work twice. GCC main vectors. Okay, good. That's good. So then we can say enter a vector four, 3, 5, 2, 8, 2. Then we can just display vector. Okay. So let's do 3. So let's do, here's the base case, 0, 3, 3, 0. This gives us a resultant of 3, 3. 3, 2, 4, 5. Okay. So now the cool thing that I saw was we could get a like normalized vector, and basically I think the way we did it is if we want to do what's the double norm vector, or let's do vector norm. We'd basically get, we would dot product itself, so we have to define dot product. Double dot product. So basically what the dot product is like a special matrix operation. So a dot product is essentially, so P So it's basically the two x coordinates multiplied together and the two y coordinates multiplied together, I think. So you get turn the, so a dot x times a dot b dot x plus a dot y plus times b dot y. And this basically gives you your basic dot product. And then we can say if we want to get the norm, and the norm is basically the length of the vector. Oh, the norm is the unit vector. So if we want to just get the length, vector length, this is what you're actually getting. So this is basically, it's the dot product of A times itself. Then if we want to get the unit vector, vector to unit vector, it's and then I almost forgot. Let's do vector 2 0 0. That's just a 0 vector. For the dot product, we have to square root it. So we'll just do square root. So this gives us the length of our vector. And then if we want to actually get the unit vector, we basically take each aspect of it and then divide it by its vector length. So let's call this, we'll duplicate this. So we'll move main.c to, let's call this just a vector addition.c, and then copy vector addition.c to vector length.c. Then we're going to go to vector length.c. We're going to ignore, well, we're going to keep this. So we're going to delete this. Well, we'll move it to vector length will be actually unit vector.c. Yeah, okay. So what we'll do, let's first compile it. So unit vector, then we need vectors.c. Undefined reference to square root. Did I not include it properly? Include nav.h. Scroot takes in a float. That's why. I feel like, am I missing something? Square root. In function vector length undefined reference. It's not good. Okay, makes sense now. So we have to actually link it properly so it actually do touch build dot. So in theory, what this gives us, it should give us, well, it just gives us a regular vector. Then we're going to get the unit vector. So vector 2 unit vector is equal to the unit vector of that. Oh, I got it now. Unit vector, let's do UV. So the function that we have should not be the same as our variable. So basically what happens is that we give it its vector, right? And then what it'll do is it'll convert it to the unit vector. So say we have the vector, like, let's say we have like 3, 4. it'll convert it down to its appropriate unit vector in theory. I mean, it's still, sometimes it might get it wrong, but it's supposed to work in theory. Obviously, I have a feeling that it's forced to round because in our vector thing, we said that they are ints. Let's make these doubles. See if that changes it. And then we have to say, well, and here we need to do this. LE, okay. So now if we do like 4, 3, then we get the unit vector as a double. I think we can do .2 maybe. Oh, well, when I display it out, .2.f. Float doubles C. Okay, that's what I was looking for. So we have it display out to the second thing. So if I did this and I said, let's do 3, 4, then we get that, which is what we wanted. So now we can probably take this. No, we can take this and put it in here. Yeah, that's better. So what can we do now? So now we're gonna do, let's do double angle between. And what this will do is it's gonna return the angle between two vectors. So if we go back to our definition of the dot product, the dot product is just A dotted with B. The dot product is A dotted with B, or A, B, the magnitude of A times magnitude of B, which gives us cosine theta. So if we do, if we say we do A times B divided by magnitude of A and the magnitude of B, right? Then, and we do arc cosine, then we should get our theta. Let's see, and I do have the vector length thing, which is our magnitude. So if we do let's copy this. So we can do say a dotted with b is equal to a and then b cosine theta. So we need to figure out what our cosine theta gonna be. Cosine theta will equal angle ratio. So let's do double angle ratio. And I guess we'll return our result in like radians if we want. This is gonna be the a dotted with b. So we'll do dot product a and b divided by the vector length of a times the vector length of b and then we just have to take the arc cosine and let's get a pi constant going. Okay, so we can do the result is a cosine angle ratio times, and then let's do double conversion equals 180 divided by pi times the conversion. So if we were to do copy unit vector dot c to angle between dot c, so that's fine. So we'll modify angle between to do this. Thank you for the follow, Reinhard von Loh. So, display vector, let's do angle between, and then we can just do reference of vec1, reference of vec2. Let's also make sure free vec2. And then, let's try that out. So let's make the first one 4, 0, and let's make the second one 0, 4. This should give us a 90-degree angle. The reason why is because the first vector and the second vector are perpendicular, so let's try something a bit different. Let's say that the first vector is say it's 4, 0. And the second one will be 4, 4. Okay, it works as expected. Oh, that's a lot of code. That's a lot of C programming. I'm trying to think what else I did in linear algebra. I feel like that covers a lot of it. Let's see. Unit vector, get vector, display vector, vector length, unit vector, angle between. Yeah, that's what I got from my first chapter of linear algebra. Yes, that's the one. And then what else? And then there's C++. Matrices, yeah, I haven't gone, I'm only on chapter 1, so we've only been doing 2-dimensional vectors. I guess I could convert this to 3-dimensional. But you can't really get a 2-dimensional angle in 3 space unless you split it up into 2 different 2-dimensional vectors. Yeah, matrices in my book, I just haven't gotten to that chapter. I'm on chapter 1. A matrix should just be matrix would be like you'd have your row, well, you'd basically have a nested set of cells, I think. So you'd have like, so a cell would be typed F, struct cell. And then this would just be a, oh, this would also be, no, I guess, yeah, I feel like that would do it. And then you would write the code to make it figure it out. And then this would just be a cell double pointer. So a pointer to a pointer of a cell. And what you'd say, just be cells. Or you would have a, yeah, you'd have pointer to cells. And then you could do some stuff like on the fly generating the XY coordinates and stuff like that. And then you could do the math on it, but. And then I guess, because you can define the vector 2 as a subset of it, but I haven't gotten to that part. So this is how you would do it, just purely algebra. Yeah, you can do a dot product on the 3D vector like that, I know. But it's about like what you would do after that, basically. Yeah, I know. I'm trying to remember. Whiteboard. They saw the dot product as column vector. Oh, well. You have a row. Say row vector times a column vector. Or column matrix. If you have just a general matrix, you have a bunch of items. And you need some way to traverse it, you know. And I guess, so you have the rows. And then you have the columns. Let's do this. Rows, columns. So I guess the function would have to be like get. You'd have the matrix. And this matrix would have a width. No, it'd have the number of rows, number of columns. So I guess you could just say, well, I know I'm going to have such and such rows and such columns, so I can just make a cell. And I guess, well, I don't want to, well, I guess worst case scenario is like O to the n squared if you're just brute forcing it, because I don't know any other way off the top of my head. You could see what they do. Matrix implementation. Rows, columns. They basically create a bunch of rows. So the matrix is the size of the rows. So they just do a two-dimensional thing, and then you can get the rows and you get the columns, and that's it. So they just do, that's what I was thinking. You just do nested for loops. So you just have it where it's like, okay, cool, blah blah blah. We could do some naming convention, but at the end of the day, you'd have the thing. If you really want, you could say, well, this guy here, I know for sure will always be at column, like row 0, column 0, right? But that would suck if you have to resize the matrix. But I guess for simplicity, you would just do a tile or a cell. A cell would have some value, and then it's the job, and this would just essentially just be a double pointer, basically. And so it'd be, one of them would just be so it's a pointer that points to the pointers for each row. That's why you get two-dimensional matrix. And then you would write the functions for that, like the turn, like how would I do? So what is dot product matrices? How would you do it matrix wise? Dot product in matrix notation. So dot product is basically flip one, and you flip one matrix and the other one, and it's basically matrix multiplication. What are the rules of matrix multiplication? Matrix vector, great. Matrix product. The product AB is an M times P period, which we call C. AB equals C. We view as okay. Yeah. So we flip one, and I don't think, the thing with the matrix multiplication is I think it's like, you can only go one way. So it's 0 times 0, 4 times 1. And the end result, end results is interesting. But there's an algorithm to this, I suppose. Yes, great. Yeah, I understand that. Let's go with the definition. Okay, given this stuff and that stuff, and the resultant, such that Cij is equal to a times blah plus blah 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 for I to n. Okay. Ij to mj, I1 to m. Illustration. A 4x2, 2x3, this one and that one cancel out, you get a 4x3. Intersections are marked with circles. I'm gonna figure this out tomorrow. I'll figure this out when I get to that part. Let's say that'll be a challenge. But essentially, this is decent for two-dimensional vectors. The matrix thing is just like, how do I articulate this in code? Pretty much. I'm trying to think what else. If I can figure that out. I just remember that I remember that this matrix thing was so freaking terrible, at least when I was doing it in middle school. Or not even middle school, when I was doing it like as a sophomore in high school. For, I don't know, what was it, algebra? Something to do with like, I don't know why they were telling us to use these stuff. It's whatever. If you want an example, or since I have all you guys, that's not it. I just released a game. Let's see. So if you guys want to play it, if you want, there's a demo and stuff. Because it might look like I haven't programmed like ever before, like because of how much I'm struggling with C, but I have programmed before. This is just saying type of thing. But I feel like I'll figure this C stuff out. I feel like I'll just have to force myself to program things in it. And I feel like as I continue to program things in it, it doesn't seem as like, it gets less terrible. It's just there's so many constraints I'm not necessarily used to in a programming language. That's kind of the main thing with it. I'm trying to think. Let's see. So let me look at my schedule real quick. Trello. I'll get to C++ at some point. It's just like I'll like do C++, and then I'll realize that C++ is better. But at my college, they're teaching the first year of CompSci in C. So if I get too used to C++, then I'll be like, okay, what part is C and what part is C++? But I feel like I can tell the difference. I would just have to not use C for like, not use C++ for a little bit. Let's see. So I coded C for a little bit. How do I design programs? Let's see. I guess I could. Wait, I guess I would have to change the title of the stream since it's not going to be. Let's see. How do I change the title? So instead of learning C++, it would be learning. Oh no, my YouTube went down. Okay. So I'm going to turn off the stream for a hot second, and then I'm going to change the title because we're going to be doing a slightly different CompSci related thing. So I'll be right back. Okay. Okay, can everyone see me now? Yes, no, maybe. Question mark. Yes, okay, awesome. Great to hear. Okay, so we're gonna be doing, if you can tell that I changed the title. Okay, we're gonna be doing how to design programs, how to design HTML. Okay, how to design programs. It's a book from MIT, and I'm gonna probably do this for like half an hour, if I can remember where I stopped. I think I ended up on structures. Oof. Okay, let's close some stuff out. Okay. So this book teaches like programming concepts, but it uses this language called Racket, and then Racket has these sub-languages. So basically for this book they designed a sub-language that pretty much, how'd I put it? It like makes things easier. So right now they're talking about structures and what they're saying. They have structure already in place. They use Possum. Let's see what that does. And then let me know how the font size looks on this, or what I should change. Should I make it darker? Because it may or may not be hard to see. Oh, I'll make it this big, and then I'll make the color, let's do this. That may or may not look good. Let me check the OBS. It looks okay. So let's see. +1 1. That's a basic one, but I think what they were saying. If I check here. Make possum. Alright. Make possum 1 1. So this creates a position structure. And then they're like, well, here's a possum. And then this whole chapter it's on right now is fixed data structures. So what that pretty much means is that they're assuming you have these variables, but you're not really changing those variables all that much. How many people are viewing me from YouTube? Does it say? No, it doesn't. Okay. Yeah, I would say that this is not necessarily as exciting as C in my opinion, but it has some quirks to it. But this is mostly skimming through it. Programming with Possum, distance to 0, what they're saying. Pos X gets this X position. No. Make pos. So, oh, okay, that makes sense. So it just gets the X and Y position, then you can do specific functions, distance. They give you this formula, which is fine. And this is distance to the 0 vector. We rigged some examples, that's fine. Manhattan distance to a point considers that it's a rectangle grid. So Manhattan distance will always be the x vector plus the y vector. Makes sense. I mean, and if this is, what is it, relative to the origin, yeah, makes sense. Defining a structure. Define a structure Oh no. It's almost like they took this right out of C. This is... I thought that I was away from this. Oof, okay. Define struct. Alright. So could I do the same thing again? Can I do define struct xy? Let's do vector2 xy. Yeah, we can do that. And then we can do the thing about Racket is it's not, I think there's no fixed types really. You have to like remind yourself. Define struct entry name phone email. Okay. Then we can create a function. Right? Yeah. We can define struct location ball. Both fields are going to contain numbers, so make ball is a good data example. Oh, so whenever it does that, it gives you a free function called make dash whatever. So I can do 4. Okay, can I do? Is there any other parts of it I can do? Then what if I do vector 2x make vector 2 4 4. Okay, so that stuff's auto-generated. That's fine. I get that. And this is just a bunch of programs. I roughly understand what it means. Programming structures. Make a position. Oh, this is for the documenting it. Entry tells you what it can do. Your team is designing an interactive game program that moves a red dot across 100 by 100 canvas and allows players to use the mouse to reset it. This is how far you got. So I guess with the structure, then you can represent a much more complicated state. Sample problem. Let's try this one. That seems simple enough. Did not. Okay, so we had an extra one by accident. Function call. Am I missing something? Pos and x p x plus p pos in x p. So let's start with basic example, right? Now it compiles, and then we can say this is 3 plus pos in x p, and then this is pos in y p, and that compiles, right? And then we can just do x plus make pos in for 3. That is what it does. Okay, perfect. So I can do that. Take a bunch of inputs, transform the input, do other stuff with it. UFO, velocity, position, UFO, got it. I don't know why, but stuff like scheme seems harder to read. I feel like it's easier in certain aspects. In other aspects, I definitely agree. It does seem a bit harder to read. Every language comes with a universe of data. Here's the real universe. No, here's the universe. And here's a sub-universe inside that universe. BS. Yeah, it's BS data. It's not, it better not be a real data type. I was about to say, BS should not be real. Okay. And yeah, some of the instances of Poisson make no sense to us at all. Yes, they properly don't. But it's a sub-universe within the universe. And a structure can have nested structures within those structures, which is crazy. Oof. Poisson is make Poisson with more structures. So what's the point? So we have to read the code. Yes, I understand that. Color is one of the following. Create examples of the following data definitions. So there's not necessarily a way to limit it to this though. Dog. Designing with structures. Design a function that computes the distance of objects in a three-dimensional space to the origin. Ooh, okay. Let's do create. What was the function? We gotta define a struct. Let's define a struct. Let's call it v3. Let's make it x, y, and z. And then we have to get define 3D distance, which will take a point in that three-dimensional space. And then we have to take the square root. Is this for a course? No, I'm just doing it so that way I have some like just better programming knowledge, better CompSci knowledge. Let's do the square root of the sum of the v3x p v3y p. Yes, that is correct. The v3 z p. Then let's square. Yeah, okay. Define p3 to be a make v3 111. That. Then let's do 3D dist of p3, which should give us 1. Oh well, I guess. not 1 times 1 times 1. 1 plus 1 plus 1 is 3. Square root of 3. Yeah, that makes sense. And this book has you using Racket. That is correct. Structure in the world. This is the state of the game. Oof. Oof. Okay, I was about to say. Have you looked into static dialect type Racket? Not really, because I'm mainly using Racket. As of right now, I'm mainly learning Racket in its I'm learning it in a educational context. So I'm sure that I can get a dialect version of it, but I don't think that it would benefit me as of right now. So is it just Racket but with types? Is that basically what it is? Type of thing, or how does it go? Space game is a structure. Okay. I mean, I think Racket's at the end of the day, they're all very similar to some extent, I think, with the Lisp stuff. If you're looking, blah, blah, blah. Text entered. Imagine a structure. Editor, pre-post. Okay. Oh, not again. The virtual pets. Is this example code? No. Maybe. Library support would be a factor. I think the one that I would use in terms of library support would either be Clojure. Because Clojure has a pretty... It gets up there. Another one is just, I think, just the low-key, just common Lisp, as far as I know. Because, I mean, common Lisp has been around for a while, I think. But yeah, Clojure is the hot one. It's just what I don't particularly like about Clojure, at least what kind of partially turns me away, is the fact that it runs on the JVM, which is like okay, but I feel like JVM kind of limits a lot of things, basically. Because, like, it's good, but I feel like JVM slows it down quite considerably. So, virtual pets worlds. Define a structure type that keeps track of the x-coordinate and its happiness, then formulate a data definition for cats, dubbed vcat, including an interpretation. Define a happy cat world program which manages a walking cat and its happiness. Let's assume that the cat starts out with perfect happiness. Okay. Modify happy cat program for proceeding. Extend your structure definition. Yeah, I think I might. Do you know what I could program in it? Well, I guess I could program games maybe in it. Yeah, I posted on there today. I thought I might as well. Adjust your happy cat program so that the cat moves in specified. It's chameleon. It's chameleon. Chameleon. It's a chameleon. That's good though. That means I'll continue to post and watch people code, since that seems to work out fairly well. So they have chameleon, and then there's background, and then they overlay the chameleon on top of the background. Got it. Okay. When it reaches the right end, it disappears. Immediately appears like the cat. Oh, poor chameleon. Okay. Copy your solution. Have some Italian pizza. I love this book though. This book is really funny. Itemizations and structures. Am I near the end of this? Preceding 2 chapters. Oh, that was. Am I in chapter 6? Is this chapter 6? Preceding 2 record description. Record was designed. Thus, record distribution, network, web development. Yeah, I get that. I mean, you can build anything with anything, as weird as that sounds. But though, certain things are more suited, certain programming languages are better suited for certain tasks. Yeah, it is. Itemizations. Design a game program. For a play simple Space Invader game, this I will try out maybe tomorrow if I have extra time. This Space Invader game. Following 2 subsections. It's I think it's a sub language of Racket. It's basically a programming language called Arc, so it's there. Following 2 subsections, sketches, itemizations. First, so what's itemization? I think I missed something. I think I might skip something. Itemization. So itemization is basically just itemize. Okay, that makes sense. You itemize things. Got it. The first step, to find the items. Okay, makes sense. Here, blah blah blah. Make aim. See, so they have a structure. And that structure is made up of 2 substructures. Okay. This one is just like the previous one, but the missile has been fired. Okay. And the cool thing is, like, when it comes to this, and I mean, if we're keeping it towards like a pure function standpoint, I mean, this is you build a function, takes in the structure, you tell it to return a new version of the structure, and then any stuff that you don't update, you just get the previous version of that structure. Of course, but I mean, I think relatively this BSL Racket dialect is pretty good for like learning this stuff. So defining data, this is all stuff I should do. This is all like best practices, I suppose. Body, cond. Fill in gaps, templating, that's good. If you're stuck on some cases of itemize, okay. Reread the description, compare it to this revision. Signature of rendering sigs, which I guess is state. Go to image, which is a tank, missile, to the background. Here's a tank missile background. Are requested, so we make the aim, we make it fire. We render it. This is a game space. Okay. Rendering the Space Invaders. Tank rendering. Okay. So it's a lot of, I feel like it leans a lot towards like, okay, you have something, and then implement it. Okay. It's animals, more structures. Following images for pedestrian streetlight, that's cool. This is finite state machine. A goes to B, C goes to the back itself, D goes here. You can't really go anywhere else from there. These go here. Can't go anything from there. So your two best scenario is this. So you want to stay in here maybe? I guess it's more like you want to keep the person happy. I think finite state machines are pretty cool though. Then Stephen C. Klein invented regular expressions as a notation for the problem of recognizing text patterns. For the above problem, Klein would write, which means that followed by B or C, or arbitrarily often, which means A is followed by B or C, often until D. So this just matches that of like eventually reading that whole pattern, I suppose. Input errors like, hey, blah blah blah, you got this wrong. Any BSL, any is the value, that's anything. Okay. Number expected, so test for the number, got it. So you could write functions to check if the thing is a valid type, which I feel like to a certain extent that's good, but then like you kind of do want to have it where like, hey, oof, no, like figure that out, I guess, this itself. Then equality predicate, okay. Quality predicate, I feel like I've encountered this before. Recall the definition of a traffic light. So let's define is it a light function? Well, it's a light if it is either red, green, or yellow. It's not a light if it's anything like this, or like this. Well, that's a Boolean, but 10 is not a number. 10 is not a Boolean. And well, actually, this is also a string. These two are not strings. These two are not strings. These two are not equal. These two are not equal. Unless somehow this, some weird way it is, but I highly doubt. Then this could be case sensitive, which means, I mean, you could just you could just lowercase the value first before you actually utilize it. Let's see, define a message, just constant message. Check the expectation. Hey, is it what it's supposed to be? You know, it for the light. Summary. In this first part of the book, you learned a bunch of important stuff. A good programmer designs programs. A bad programmer tinkers until the program seems to work. Design recipe has two dimensions. One concerns the process of design, the other sequence steps to be taken. Every well-designed program consists of many constant definitions, structure type definitions, data definitions, function definitions. For bash programs, one function is the main function, typical composed of several other functions. The structure program's Big Bang function plays the role of the main function, and it specifies an initial state, which basically I feel could be implemented recursively at some point. And then, like all programming languages, BSL, which is the version racket they're using, or DSL, domain-specific language, has vocabulary and a grammar, must have meaning to each sentence, so it's like, hey, you know, blah blah blah, programming language. It's a programming language, thus it has to have some set of fixed rules. Programming languages, including BSL, have a rich set of libraries, so that's great to have, especially if it's something like C. Doing so simplifies life. A programmer must get to know the tools that a chosen programming language offers, such as cond or max, imported from a library. In the spirit, make sure you understand the following terms: structure type, function definition, constant definition, structure instance, data definition, Big Bang, event handling function. Wow, that's a lot of stuff. That's a lot of stuff. Okay. So I'm gonna have to take a little bit to process all of that, amongst other things. So before I end the stream, does anyone have any questions? Anything regarding what I'm studying, about me, stuff I've built? Go ahead. No, not at this time. Okay. Anyone else? Thank you. Well, I would hope that everyone has a good morning, good night, or good afternoon, wherever they are in the world. Yeah, I'll parse and archive this stream on YouTube, so there'll be that. If you want to stay updated with a bunch of art stuff I'm doing, and I would recommend following or subscribing to my YouTube, both for the same username. You can also stay up to date in terms of like other stuff I'm working on by visiting this website, which I don't know necessarily if I can post links. I guess I can post links into Twitch because I'm the person streaming, so that's a main reason why. But yeah, so that's all for today. Thanks for watching and tagging along on this journey. So see you guys next